So dear students, so let's start our class in continuation of whatever we have discussed so far on theory of equations. So today, what I'm going to discuss is, equation reducible to quadratic equations. We will see that there are some equations which are more than, that their degree of these equations are more than that of a quadratic equation. And we will see that how we can, reduce those equations to a quadratic equations and solve it. There is a purpose behind it. Why so? And apart from that, quadratic equation of degree more than 2, we will see how to, transform other type of equations, kind of an, uh, you know, uh, where the it is not exactly polynomial equation, but other type of equations like exponential equation, logarithmic equations, how we can actually convert it to a polynomial equation of degree 2. Specific problems we will see, and then we will understand the essence of it, why it is so. Because why we are going to transform into in a quadratic one, because we are smart in solving quadratic equations. For example, by now, if I give you a quadratic equation, you can easily solve it, right? So it is important that if I give you a biquadratic equation, rather than solving that biquadratic equation, it is better to convert it to a quadratic equation and solve it. And we will see different techniques how to convert those biquadratic equations into quadratic equations. And it is always good to go with some examples. So dear students, the first example what I'm going to show you is something like this. The first example what I'm going to show along with you, is you can also open your notebook, dear students, do along with. So the first question is the solve the equation 2x to the power 4 plus x cube minus 11x square plus x plus 2 equal to 0. Point is that, dear students, if this equation is given to you, then what comes to your mind? Okay, as it is a biquadratic equation, so it has 4 roots, correct or not? As it has 4 roots, let's assume the roots are alpha, beta, gamma, delta. Then you can find the relationship between the roots and coefficients, correct? What is the traditional approach? If you assume the roots are alpha, beta, gamma, delta, then what you can write? Alpha plus beta plus gamma plus delta is equal to minus 1 by 2, correct or not, dear students? It is the minus of coefficient of x cube by coefficient of x power 4. Then 2 at a time, that is alpha beta plus alpha gamma plus alpha delta plus beta gamma plus beta delta plus gamma delta, correct or not? That is equal to what? Minus 11 by 2. Then we'll take 3 at a time, alpha beta gamma plus alpha beta delta plus beta gamma delta, correct or not? That is equal to minus 1 by 2. And then finally alpha beta gamma delta, that is equal to 2 by 2, that is 1, correct or not? Now, general principle, dear students, is that if you need to solve, you need to find the values of some unknowns, you need to have that many equations. What does it mean? If you need to find the value of 2 unknowns, it is important that you have 2 equations given. You need to find the value of 3 unknowns, it is important that you have been given 3 equations. Similarly, here there are 4 unknowns, alpha, beta, gamma, delta. and we get four equations. Correct or not? But it is difficult from here, dear students. If I tell you, use your fundamental concept of algebra and find the value of alpha, beta, gamma, delta from these four equations, you can find it out, but it will take long time. It is going to take very long time. Correct? You can experiment if you have some time after the class. Not some time. If you have some longer amount of time, you can try with it. But so I am giving the justification why it is important to convert it to a problem which is related to quadratic equation, because it will make our lives easier, simpler, and that is why to give this justification I explain what is the traditional approach. Traditional approach is that whatever I said in the last few minutes. Now then, what we can do, one thing we can do, dear students, if you look into this equation, is x equal to 0 is the root of this equation? No. Correct or not? X equal to 0 is not a root to this equation. Because if you apply x equal to 0, then what you get? Left hand side you get 2 and right hand side is 0. So that means x is equal to 0 is not a root to this equation. So we can divide both sides of the equation by 2x square. So what we are going to do is that we are dividing both sides of this equation by x square. So what I was telling, since x equal to 0 is not a solution to the equation, okay, what I'm going to do is that I'm dividing both sides of this equation by x square. What we'll get? If I divide both sides of the equation by x square, so we get 2x square plus x, correct or not? Minus 11 plus 1 by x, correct or not? Plus 2 by x square. Clear or not clear? After that, what we're going to do, dear students, so you can write, since x square is not equal to 0. That's where we are able to do it. So from here, what we can do, dear students, that 2x square and 2 by x square, we can take 2 common. What we get? X square plus 1 by x square. Correct or not? Plus we can write x plus 1 by x. Correct or not? And minus 11, that is equal to 0. Clear, no? Anyone has any doubt, please do let me know. After that, what we are going to do? We are going to apply, let x plus 1 by x is equal to, y. Okay. Or we can a little bit simplify it also. So this implies 2 into, what is x square plus 1 by x square? It is x plus 1 by x whole square, a plus b whole square, correct or not? Minus 2 into x into 1 by x, correct or not? Plus x plus 1 by x minus 11 is equal to 0, correct, dear students? So what we are writing now, let x plus 1 by x, that we are assuming as y. Okay, so then what we are going to get from these above equations, 2 into y square minus 2 within bracket plus y minus 11 equal to 0. This implies what, dear students? 2y square plus y minus 15 is equal to 0, correct or not? All of you got it, dear students? So then from here, so what we achieved? If you see in x, it was a biquadratic equation, but what we have done? We have resolved it to in a quadratic equation like 2y square plus y minus 15 equal to 0. Now 2y square plus y minus 15 equal to 0, if you solve it, I'm not spending time in solving it. You will get y is equal to either minus 3 or 5 by 2. Correct, no? You will get the values of y as equal to minus 3, or the value of y you will be able to get is 5 by 2. Now, once you get y is equal to minus 3, Once we get y is equal to minus 3, that implies what? That implies x plus 1 by x is equal to minus 3. So now you get a quadratic equation, dear students. Correct or not?
Yes.
X plus 1 by 3 is equal to minus 3. If you solve, you will get what? It is x square plus 3x plus 1 is equal to 0. And again, when you apply x plus 1 by is equal to 5 by 2, so what we are going to get? We are going to get is that x square plus 1 is equal to 5x by 2, or you can write this implies 2x square minus 5x plus 2 is equal to 0. Now both are quadratic equation. Originally that equation is a biquadratic equation, and we know that biquadratic equation has 4 roots maximum. So we need to find those 4 roots. Now we are able to find it out. No? If you solve x square plus 3x plus 1, what we are going to get? X square plus 3x plus 1, if you want to get, just write this thing. Minus b, that is minus 3, plus minus square root of b square, that is 9. Correct, na? Minus 4ac, that is 4. Correct? Divided by 2. Correct or not? And if you solve it here, at the right hand side equation, what you are going to get? You are going to get x is equal to, we can do a middle term factorization here, I think. 2x square minus 4x minus x plus 2. So from here we can take 2x common. So x minus 2 minus 1 common. X minus 2 is equal to 0. So from here we can take x minus 2 common. Then 2x minus 1 is equal to 0. So this implies x equal to 2 and or x equal to half. And from here what we are getting? X equal to minus 3 plus root 5 by 2 and minus 3 minus root 5 by 2. So finally we get 4 roots. Na? So this implies x is equal to minus 3 plus root 5 by 2. Then minus 3 minus root 5 by 2. Then 2 and then 1 by 2. These are the 4 different roots of the given biquadratic equation. But see, dear students, how efficiently we are able to do it. This is one technique what you can follow. But dear students, when you can apply this technique? You can apply this technique whenever you see that coefficient of x power 4 and the constant term are same. Coefficient of x cube and coefficient of x are same. You see, dear students, if I look into it, the problem now, how to approach it? For every problem we are able to solve it like this? No. For every biquadratic equation, can we do this same method? No. So when we can apply, you see the coefficient of x power 4 is 2, which is equal to the constant term. Coefficient of x cube is equal to the coefficient of x as both are 1. Correct? Now, then only we are able to approach this method. So whenever you get a biquadratic equation, next time, and if you get this kind of, pattern, you are able to find it out, your mind first go to, oh, okay, let me divide both sides by x square. Subject to the condition, x equal to 0 is not a root, obviously, otherwise constant term will not come. Na? I hope it is absolutely clear to all of you, dear students.
Yes.
And then I'm going to discuss about the next question. So before that, I can share this entire solution. You can have a look into it, proper solution, the way it is there in my study material, which will be available to you also. All the study material will be available to you, dear students, in due time. All physics, chemistry, mathematics, biology, all study material will be available to you. Correct, no?
Yes.
Okay, great. So now let's look into a second problem, how to approach this kind of problem. Okay. And the problem, I'm giving a little different type of biquadratic equation. So here the question is that, and the question will be available to you in few seconds. So it is a different type of questions, dear students. Find the real roots of the equation 6 minus x power 4 plus 8 minus x power 4 is equal to 16. So how to approach this kind of problem? This kind of problem is different than the problem whatever we solved in just few minutes back. If you look into this equation, we need to make a change of variable. This concept is called the change of variable. So what is the change of variable, dear students? That I am introducing one variable called y, which is nothing but 6 minus x plus 8 minus x divided by 2. So if we do this thing, then what we are going to get? We are going to get that y is equal to 7 minus x. Correct, dear students? That implies x is equal to 7 minus y. Correct? So this is an important observation that, x is equal to 7 minus y. If x is equal to 7 minus y, then if we apply that value in the given equation, what we are going to get? So what is our original equation? It is 6 minus, just a minute, 6 minus x power 4, correct or not? 6 minus x power 4 plus 8 minus x power 4 is equal to 16. That is our original equation. No? Now in that equation, if we apply that x is equal to 7 minus y, then what we are going to get? We are going to get y minus 1 whole square, correct or not? We are going to get y minus 1 whole square, 7 minus y, x is equal to minus 7 plus y. So y minus 1 power 4, y minus 1 power 4 plus y plus 1 power 4 is equal to 16, correct or not, dear students? Now, if you make this thing, if you simplify, you will see that few terms will get cancelled, isn't it? Then finally you will find that y power 3 term will get cancelled and y term will get cancelled because those are the negative and positive terms of the corresponding expansion. If you remember your binomial theorem days, y minus 1 power 4 will be what? First term plus, second term minus, third term plus, fourth term minus, then fifth term plus. In the same manner, if you do the right hand side, it will be all the term plus, no? So then the coefficient, the term related to y power 3 and term related to y will get cancelled. So what we left with? We left with y power 4, y square and constant term. Got my point? So if you do this thing, if you simplify, then what we are going to get, dear students, is that you will get something like this: y power 4 plus 6 into y square minus 7 is equal to 0. I'm not spending time on this because there is a simplification and that is not exactly part of this theory of equation. But the moment you get it, you can make a middle term factorization, dear students. So what we get? You will get y square plus 7 into y square minus 1, that is equal to 0. Correct or not? Clear or not clear? So this implies either y square plus 7 equal to 0 or y square minus 1 equal to 0. Correct or not?
Mm.
Y square plus 7 equal to 0 or y square minus 1 equal to 0. Now think about, dear student, y square plus 7 equal to 0 means what?
Y square equals to -7.
Minus 7, that means y equal to plus minus square root of minus 7. That means it leads to imaginary root, correct or not? But according to the question, we need to find the real roots, correct? No? So we should ignore this y square plus 7 equal to 0. So we should focus on y square minus 1 equal to 0, correct, no, dear students? So that means what? Y square is equal to, y square minus 1 equal to 0. Now what is y in terms of x? If you, okay, y square minus 1 equal to 0 means y square equal to 1. That means we get y is equal to plus minus 1. So now if you take y equal to plus 1 and y equal to, so that means what? You can write like this. Y will get two values. One is plus 1, one is minus 1. When you take y equal to plus 1, what is the value of x you are getting to get? It is 7 minus 1, that is 6. It is coming from this relation, na? That x is equal to 7 minus y. And when you write y equal to minus 1, then what we get? X is equal to 8. Correct or not? So what are the two real roots? One is 6 and one is 8. So real roots are absolutely clear, right? 6 and 8. And we can see this problem in multiple ways, okay? Now, originally this equation is a biquadratic equation. As it is a biquadratic equation, he said it has four roots, na? Real or complex. We found two roots. Other two roots will be what? They are imaginary. But they will come in complex conjugate. And that we will get if we do y square plus 7 equal to 0. As in the question it is given the find the real roots, we are not spending time to find the imaginary roots. But if the question is that find the roots of the equation, 6 minus x power 4 plus 8 minus x power 4 is equal to 16, then you need to solve this part also, and that is also quite easy. What we are going to get? Y square plus 7 equal to 0. That means y is equal to plus minus square root of 7i. And then put x equal to 7 minus 7 minus plus I into square root of 7. So they are coming complex conjugate, not dear students. So this is also another approach. So what the approach we are seeing here, that is called the change of variable. Now for your convenience in future, I'm just going to send you the entire the way the exact solution I have written in the study material. But I explain that why it is actually how you obtain this thing. Later you can follow this thing, and so that you will get the exact idea.
Sir, how are we taking y equals to 6 minus x plus 8 minus x by 4?
Okay, very good question. Appreciate. We will do when we get it. It is both are linear inside. 6 minus x and 8 minus x both are linear inside that. That linear expression power 4, na. And
Yeah.
whenever we see this thing, then only we'll apply the change of variable concept.
Okay.
Got it, na, dear student? Absolutely clear, right?
Yes.
Huh. For example, we definitely not apply the concept of change of variable, whatever in the previous question. Definitely not. So what will be your approach whenever you get a biquadratic equation? First, your approach will be whether, let me see whether the coefficient of x power 4 is equal to coefficient of the constant term or not. Coefficient of x cube is equal to the coefficient of x or not. Then we'll approach the method what we just learned previous section, no? Not just learn previous section, whatever we have done. This one. Correct. Now, next one is that if it is not like that, then you see whether it is a linear expression power 4 or not. If it is, then let us apply the change of variable concept. That's what I have written it here, dear students, that change of variable. Correct? Now let us look into a different type of problem, dear students. Okay, so let me take you to the any question before I proceed. Is absolutely clear this thing, sir?
Yes.
Okay. Okay. Now let me take you to the next problem. That problem is so it is a little different type of problem, and you will see that how our fundamental knowledge of linear inequalities are going to help us. By the way, dear students, these kind of questions will not come in your board examination. These questions will definitely important. At the same time, these questions are very important for your entrance examination, engineering entrance examinations. So what is the question here, dear student? The question is that find all values of A for which the equation has at least one solution. And you see the equation is not a polynomial equation. Correct? Huh? So, and question is that has at least one solution. That statement as a, you know, significance. So let us see how we can solve this kind of problem. So what is our equation, dear student? Our equation is that 4 power x, our equation is 4 power x minus a into 2 to the power x. So 4 power x minus a into 2 to the power x minus a plus 3 is equal to 0. Now, whenever you get this kind of problem, you see that 4 power x is nothing but 2 power x power 2, na? Correct? So, if we assume that let 2 power x equal to t, what we are going to get? We are going to get t square minus at minus a plus 3 is equal to 0. So, the given equation now very easily transformed to a quadratic equation, na, in t. After that, what we will do? So what is t? T is equal to 2 power x. Let's focus on that. 2 power x should always be greater than 0, na, dear student. Whatever the value of x is, 2 power x will be always greater than 0. That implies what? That implies, so let me write it here. 2 power x is always greater than 0. That means t is always greater than 0. That means what? That means the equation, what you see, dear students, that t square minus at minus a plus 3 should have at least one positive root. Correct or not? Because the value of t is greater than 0. So the equation should have positive root, right? No, at least one positive root. It may possible that why the at least one positive root? At least one positive root because it may possible that equation have both the complex root, na? Complex conjugate root. Possible? Correct or not? So, or it can have, uh, you know, uh, you know, both the positive roots. Correct. So, how to solve that one? Now, let's find the discriminant. What is the discriminant of this equation? What is the discriminant? Let's find it out. Discriminant D. I'm just explaining here, dear students. After that, I'll send you the detailed solution. Discriminant is what? B square minus 4ac. What is B? Minus a. B square minus 4ac minus 4 into 1 into c, that is minus a plus 3. Correct, no? So this implies what? So discriminant must be greater than equal to 0. Correct or not? So this implies what? Why discriminant is greater than equal to 0? Because it has real roots. Correct, no? It cannot have complex conjugate root. So we are confident that it has to be greater than equal to 0. Why equal to 0? Because it can have equal roots also. Both the root, because we cannot say now, because what is the value of a? We do not know. So in generic concept, what we can say is that d is greater than equal to 0. And then what we are going to get if we simplify, dear students? We get a square plus 4a minus 12. A square minus 4a, sorry, a square plus 4a, it should be a square plus 4a minus 12 is greater than equal to 0. So from here, what we are going to get, dear students, this implies a plus 6 into a minus 2 is greater than equal to 0. So now, if you apply our concept that x minus alpha into x minus beta is greater than equal to 0, that means x is less than minimum of alpha and beta, or x is greater than maximum of alpha and beta. In this case, it is less than equal to and greater than equal to, right? So what we can write? We can write a belongs to minus infinite to minus 6 closed interval union 2 to infinite. Correct? I hope you agree to me. Now, let us look into the question. What is the question? Question is to find all the values of a for which the given equation has at least one solution. That is the question, dear student. So then what are the values of a you are going to get? That there are two sets. One is that minus infinite to minus 6, and another one is the 2 to infinite. Now let's assume that roots of the equation, that is what is the equation is given to us now, that t square, let, so I'm writing, let the roots of the equation, let's the roots of the equation, let me write the equation. The equation is that t square minus at minus a plus 3 is equal to 0, b t1 and t2. Correct? So then what we are going to get from the relationship between the roots and coefficient? We can write t1 plus t2 is equal to minus b by a, na? So that is equal to a. Correct or not? And t1 into t2 is equal to 3 minus a. Minus a plus 3 means 3 minus a. Clear? Now, let us focus on that solution, what we get. So, there are two sets. So, this is what we, conclude now. Now, when a is belongs to minus infinite to minus 6, when a belongs to minus infinite to minus 6, what we can say? We can say that definitely t1 plus t2 is less than 0, na? Because t1 plus t2 is equal to a. And if that a is a negative number, correct, na? That means what? T1 plus T2 is less than equal to 0? Less than 0. And what about T1 into T2? T1 into T2 is 3 minus A. That means we can say T1 into T2 is greater than 0. You're getting my point?
Yes.
A belongs to minus infinite to minus 6. That means T1 plus T2, which is A, has to be less than 0. And again, T1, T2 should be 3 minus A. Na? So any value of A between minus infinite to minus 6, 3 minus A should be positive. Because you are subtracting any negative number from 3. So it should be positive, right? So what we get? T1 plus T2 is less than 0 and T1 into T2 greater than 0. Think about the fundamental algebra. That means both T1 and T2 are negative. Na? It is impossible to have T1 is positive and T2 is negative. Correct, na? So T1 is negative and T2 is also negative. That's why T1 plus T2 negative and T1 T2 positive at the same time. Correct? So this implies what? This implies both T1 and T2 are negative. Correct? Both T1 and T2 are negative. Clear or not clear? An original equation has no solution, because what you need to find, you need to find the solution. If you look into this question, that you know um, the original equation cannot have solution because t1 and t2 both are positive, na. What is t? T is equal to 2 to the power x, correct, na? We took t equal to 2 to the power x, and we are getting t is negative. Is it possible to have 2 to the power x negative? Impossible. So our interval of a belongs to minus infinite to minus 6 is not going to work to conclude. Correct, no? So this implies both negative. That implies the original equation has no solution. This implies original equation, original, just a minute, let me write properly. Original equation has no solution in this interval. Correct, not dear student? Now let's find the another interval. What the other interval? Another interval we get is that 2 to infinite, where 2 is a closed interval, but infinite always is open interval. And in this region, what in this interval, what we can get? T1 plus T2, which is a, definitely T1 plus T2 is greater than 0, na? Correct. And T1 into T2 is also 3 minus a, correct. So that means what? At least one of the roots is greater than 0. If the moment we can say T1 plus T2 is greater than 0, that implies at least one of the root of T1 and T2 is greater than 0.
Yeah.
At least one of T1 or T2 is greater than 0. Clear or not clear? At least one of T1 or T2 is greater than 0. So now, that is what is our case, that we need to find the values of A for which the given equation had at least one solution. So what is the solution set we are getting? So from here what we get is that, yes, the acceptable values of A is that, so we can write is that is greater than 0. So we can say is that for, so this implies for A greater than 2 to infinite, A belongs to, not A greater than 2 to infinite, sorry, slip of my tongue. A belongs to 2 to infinite. The given equation has at least one solution, has at least one solution. So this is the way we should approach the different type of problems related to biquadratic equation and other exponential equation, and this is the way we should approach. Clear, not dear students? Okay. Now another problem, also we can think in this way. So I'm just going to show you another problem, and that is also very classical problem, dear students, and here it is. Okay, so solve the equation. If you say that x plus 2 into x plus 3 into x plus 8 into x plus 12. Okay, before that, let me first show you give you the entire solution, so that later you can follow it up. So I'm just keeping the solution here so that later you can have a look into all these things. Though I have explained, but still I'm giving the entire solution here. Now let's come to this equation. Here, all the linear expressions are multiplied 4 times. So how to approach this kind of problem? So dear student, to approach this kind of problem is that first you need to see what are the constant term now, that 2, 12, and 3, 8, they are actually matching. X plus 2 means what? X minus minus 2. Na? So minus 2 and minus 12. If you multiply, you will get minus 3 into minus 8. Correct now? So the given equation, we can write something like this, that we should club these 2 and 12 together. So what we are going to get as we observe. So here is the observation is important. What we see is that 2 and 12, their multiplication is equal to the 3 and 8, their multiplication. Correct, no? So what I should do, I should club these together. This implies x plus 2 into x plus 12, correct? Into x plus 3 into x plus 8, that is equal to 4x square. Clear or not clear? So now, if you look into this, after that the problem becomes pretty simple. So you will get an equation something like that, is that x square plus 14x. So if we make the first two terms, is that it will become x square plus 14x plus 24 into x square plus 11x plus 24 is equal to 4x square. Correct, no? Now, if you look into this equation, minutely, you will find that uh, x equal to 0 is not a root. Correct, no? So as x is equal to 0 is not a root, then you can divide both sides by x square. Correct? So what you will do? So you can divide both sides by x square. Out of this x square, one x will be divided here and one x will be dividing here. And right hand side we left with 4. So if we divide x here, so it will be x plus 14 by x. Correct, no? I'm so sorry. X plus 24 by x. X plus 24 by x plus 14 into here also x plus 24 by x plus 11, that is equal to 4, since x square is not equal to 0. After that, what you will do? X plus 24 by x you will assume as y. Correct? No? So you apply x equal to x plus 24 by x is equal to y. And what you will get? You will get something like this. It is quite straightforward. That's why I'm just, copy pasting from my relevant notes. You apply x plus 24 by y is equal to y. Correct? No? And with this, you can find the equation 3 means actually in that study material, that was the equation 3. This was equation 3. That's what is written equation 3. And after that, it is a steady flow. Correct? Fine. So with this, I would like to conclude the mathematics class as long as our theory of equation class is concerned. And